Sometimes when you solve a system of equations using linear combinations, you have to multiply both equations by some factor in order to make one of the variables cancel out. So let's take a look at these two equations. We have 7x minus 12y equals negative 22 and negative 5x plus 8y equals 14. We want to see if we can figure out what the least common multiple is. That's like the least common denominator when you're adding fractions. The least common multiple is either of 7 and negative 5 or negative 12 and 8. So let's see, the least common multiple of 7 and 5 is 35. The least common multiple of negative 12 and 8 is 24. So I think I'm going to go with the 24. And that means I need to multiply this top equation through by 2, because 12 times 2 is 24, and the bottom equation by 3, because 3 times 8 is 24. I also want to make sure that one of my equations has a positive value and one has a negative value. If not, I'd want to multiply one of them by a negative value, but here we already have a negative and a positive, so I'm going to multiply both equations by a positive. Now remember, my least common multiple, or the smallest number that both 8 and 12 go into, is 24. So I'll multiply this top equation by 2 and the bottom equation by 3. When I do that, with the top equation, I get 14x minus 24y equals negative 44. And on my bottom equation, I get negative 15x plus 24y equals 42. So the reason I did that is now negative 24 and 24 are opposites. I can now add these two equations together. The reason I can do that is by the rules of algebra, I can always add the same thing to both sides of an equation. And this equals that, so I can add this to this side of the equation, and I can add this to this side of the equation. So my negative 24y and positive 24y cancel out. 14x and negative 15x is negative x. Negative 44 and positive 42 is negative 2. So x equals 2. Now to find what y equals, I take this value of x and I plug it into either one of these two equations. I'll take the top one. 7x minus 12y equals negative 22. I plug in my value here for x, and I get 7 times 2 minus 12y equals negative 22. 14 minus 12y equals negative 22. Subtract 14 from both sides. Negative 12y equals negative 36. Divide by negative 12. Y equals 3. So my solution, remember with an ordered pair, x comes first, is 2, 3. Okay, well now let's look at what happens sometimes is you might get something kind of interesting. Let's say my system of equations is x minus 2y equals 3 and 2x minus 4y equals 7. Alright, so let's solve this by the method of linear combinations. We want to find the least common multiple of either 1 or 2, or negative 2 and negative 4. Doesn't really matter, they're both easy. Let's do this one. The least common multiple of 1 and 2 is 2. Now I want to make sure one of my equations is positive and one negative. Now in order to make these both equal to 2, I'll have to multiply the top equation through by 2. I'll want it to be negative here, so I'll multiply by a negative 2. So I'll multiply my top equation by negative 2. And when I do that, I get negative 2x. Now I'll multiply the negative 2 times the negative 2 here as well, plus 4y equals, multiply the negative 2 times the 3, negative 6. I don't need to multiply the bottom equation by anything because this 2x will already match up with this negative 2x. So I get 2x minus 4y equals 7. Now look what happens when I add. These cancel out, but so do these. And negative 6 plus 7 is 1. I get 0 equals 1. Well, no it doesn't. 0 does not equal 1. And since 0 does not equal 1, I get no solution. Now, on the other hand, let's say that I had 6x minus 10y equals 12 and negative 15x plus 25y equals negative 30. Now let's see, what is the least common multiple of 6 and 15 or 10 and 25? Well, let's see, for 6 and 15 it'd be 30. So to get 30, I have to multiply 6 by 5 and negative 15 by 2. So I'll multiply this top equation through by 5 and the bottom equation through by 2. Notice when I do that, the 5 times the 6 gives me positive 30, the 2 times the negative 15 gives me negative 30, and that's what I want. I want them to be the same value, 30, but one positive, one negative. So I get 30x minus 50y equals 60, because I had to multiply this 5 by each thing in here. Now I'm going to multiply the 2 by each thing in this equation. Negative 30x plus 50y equals negative 60, and look what happens. Those cancel, giving me 0. Those cancel, giving me 0. And these cancel, giving me 0. Here I get 0 equals 0, which it does. 0 does equal 0 and equals 0 all the time. Doesn't matter what x is or what y is, 0 still equals 0. So that means for this system of equations, I have infinitely many solutions. Okay, now we're going to look at systems of linear inequalities. Systems of linear inequalities, we usually solve those by graphing. So let's take a look at a system of linear inequalities. Let's say I have x plus y is greater than or equal to negative 2. And negative 5x plus y is less than negative 3. So I'm going to graph these. These are both linear, they're lines. So to graph them, I'm going to put them into slope-intercept form. So I'll start with this first one. X plus y is greater than or equal to negative 2. So x plus y is greater than or equal to negative 2. Subtract x from both sides. Y is greater than or equal to negative x minus 2. Okay, so now I have this one solved for y. Now I'm going to take the second one right here and solve it for y. Negative 5x plus y is less than negative 3. Add 5x to both sides. Y is less than 5x minus 3. Okay, so now I'm going to draw my coordinate axes, and I'll start with this one. Now I'm going to graph it as if it is a line. So I have negative 2 as the y-intercept, and the slope is negative 1. So I go down 1 and over 1, and down 1 and over 1. Now I have a greater than or equal to, so that means I can put a solid line through these. So I'll put a solid line through those points. Now I'm going to graph this one. This one has a y-intercept of negative 3, and a slope of 5. So up 5 and over 1. Now notice here I don't have an equal to, so I'm going to need to put a dotted line. Okay, so now we need to go back and look at our equations, and we see that this first one, which was our solid line here, had y was greater than. Well, if y is greater than that, then it means the points above, because y greater than will be above. So I'm shading in above that line. with blue. Okay, now for the next one, for this one, it says y is less than, so it's the area below the dotted line. So we'll shade in the area below the dotted line. And so our answer is going to be the area that is shaded in by both of them. And so the area that's shaded in by both of them is this area right here. Okay, let's look at another one. This will be our last one. Let's say I have x is greater than or equal to y minus 2. X plus y is greater than 1. X is less than 10. Okay, I'm going to solve each one of these for y. So this first one, I have, I will add 2 to both sides. So I start with x greater than or equal to y minus 2, add 2 to both sides. So I get x plus 2 is greater than or equal to y. But I like to read it the other way. I like the y to be on this side. So if x plus 2 is greater than or equal to y, that means that y is less than or equal to x plus 2. Notice the arrows pointing to the y, arrows still need to be pointing to the y. So that's this one. Alright, now let's look at the next one. X plus y is greater than 1, so that's this one. Solving for y, subtract x from both sides. Y is greater than negative x plus 1. So here's our next one. Our last one is already solved. Now notice this is x is less than 10, so we have to remember that x lines are vertical, y lines are horizontal. Okay, so let's draw our graph now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so x less than 10. That's going to be a dotted vertical line going through 10. And x less than, well, where is x less than 10? X is less than 10 at 9, at 8, at 7, so that'll be all on this side. Now for this line, it says y is less than or equal to x plus 2. So we'll graph it as if we had a line. We have a y-intercept of 2. We have a slope of 1, so that means up 1, over 1, up 1, over 1. It has an equal sign, so that means that we can have a solid line. Okay, this one is y, let me extend this up. Okay, this one says y is greater than negative x plus 1. So 1 is our y-intercept, our slope is negative 1, down 1, over 1, down 1, over 1. This doesn't have an equal sign, so I'll put a dotted line. Okay, and now let's look and see where we're going to shade it. Okay, it says x less than 10. So for x less than 10, here's x equals 10, x less than 10 will be on this side. Okay, now we have x less than or equal to x plus 2, that was our solid line. So y less than, our solid line. Y less than means the area below. So we're below that solid line. This last one says y greater than negative x plus 1. So that's the area above this dotted line. So the area above the dotted line. Okay, so now we want the area that was common to all of them. That's the area here in this triangle. So this area right there. And that's the solution to our system of